Hi, everyone. Today we're going to talk about the importance of cell size and more specifically, something called the surface area to volume ratio. Now, first of all, do not worry about memorizing the equations for surface area or for volume. They're all on the AP Bio formula sheet, but you do need to know how to use them and feel comfortable using them. So, why do we care about surface area to volume ratios? Well, surface area to volume ratios are very important because they affect the cell's ability to obtain resources from their environment like food, water, and oxygen. They affect the cell's ability to get rid of waste products like carbon dioxide, to either absorb thermal energy, heat, or get rid of excess thermal energy so that the cell doesn't overheat, and generally just to exchange chemicals and energies with the environment of the cell. And the more efficiently a cell can do that, the better off it's going to be. Okay, so as I said at the beginning, you want to be comfortable using the surface area and volume formulas on the formula sheet. So let's just do a sample problem. Let's say we have two cells, cell A and cell B, and they both have the same shape. They both are spherically shaped, so we'll use the same equations for surface area and volume for both of them. However, cell A is smaller and has a radius of only 1 unit, and cell B has a radius of 2 units. Which one's going to have the larger surface area to volume ratio and how much longer? How much larger? So let's do the calculation for A first. Our formula for surface area is 4 times pi times the radius of the sphere squared. So in cell A, the radius is 1, so that makes the calculation pretty simple. Whoops, I'm looking at cell B. I'm on the wrong slide. Surface area, 4 times pi times the radius squared. And for cell A, the radius is 1. So the surface area is 4 times pi times 1 squared, which is just 1. So the surface area is just 4 times pi. Easy peasy. The volume formula is 4/3 times pi times the radius cubed, okay? 1 cubed is still 1. You've got pi, you've got 4/3, so the volume is 4/3 times pi. Now to find the surface area to volume ratio, you just divide the surface area, which is 4 times pi, by the volume, which is 4/3 pi. And if you perform that calculation, the 4's cancel, the pi's cancel, and your answer is 3. So basically, there is 3 times as much surface area as there is volume. All right? That's if the radius of the cell is just 1 unit. Now, let's do the calculation for cell B if the radius is 2 units. Using the same formula for surface area, our radius squared, well, 2 squared is 4, times 4 times pi. So the surface area for cell B is 16 times pi. Volume is 4/3 times pi times the radius cubed. Now in cell B, the radius is 2. So 2 cubed, 2 raised to the third power is 8. So now we have 4/3 times pi times 8, which works out to be 32/3 times pi. To figure out the surface area to volume ratio, we take 16 times pi and divide it by 32/3 times pi. The 16 goes into 32 twice. The pi's cancel out. So what you end up with is the surface area to volume ratio is 3/2. Okay, so what does that mean? That basically means that cell A has relatively twice the surface area to volume ratio of cell B. And that's going to make it easier for cell A to absorb things from its environment and to get rid of waste products. And what do you think happens when the cell gets even bigger? Well, let's look at that. What if we had a third cell, let's call it cell C, that had a radius of 3 units? Well, if you go ahead and do the calculation, the surface area for that cell would be 36 times pi. The volume would also be 36 times pi. So the surface area to volume ratio would be 1. So as the radius gets bigger, the ratio of surface area to volume becomes less and less favorable, and it inhibits the efficient exchange of materials across the cell membrane. So, what's our conclusion from this? That smaller cells have higher surface area to volume ratios if they're the same shape and can more efficiently exchange materials with their environment. And as cells increase in size, because we do need some cells to be bigger, they'll have different strategies for increasing their surface area to volume ratio. One of the most common ones is to take the cell membrane and fold it back and forth like a piece of ribbon candy to be able to increase the surface area in the same amount of space. All right, I hope that makes sense. I hope you guys have a great day, and I will see you next